In this video, we'll deal with electrical power. We've already talked about that capacitors are used to store energy. Resistors are used to use up energy, representing motors or heating elements or other things. So power is an important thing. How fast is the energy pulled out, or how fast is the energy put in? At what rate? So power and electric circuit. Well, the power and electric circuit, any circuit, can be found by the fact that power is equal to the current times the voltage. This is always true. Take the power, take the current at a specific instant of time times the voltage in that element at a specific instant of time, and you find the power rate at that instant of time. Now, for resistors, we have a relationship between I and V called Ohm's law, and so we can substitute that in and eliminate one of them in terms of the resistance. So two ways of rewriting this formula. One is to eliminate V in terms of IR, so we replace V with IR. When we multiply it by I, we get I squared R. This is very useful in series circuits because every element has the same I. So the only thing that may differ between different resistors that are in series is R, which will, the largest R will use the most power. If you're dealing with parallel circuits, it's better to eliminate the I. In that case, you get V squared over R. And here, if you have elements in parallel, they all have the same voltage, but the smallest resistor will use up the most power. So this is best for looking at things that are in parallel. This power formulas do not work for capacitors or inductors or other things, only resistors. So this is always true. The second one is a special set of formulas for resistors. And when we talk about, for instance, running a wire where each element of the wire is in series, we talk about the power that's lost due to heating of the wire, which we don't want. We want all the power from the power company to come to your house. We don't want to heat the wire, but we can't help it. It's going to do it. It's equal to I squared R losses. So a low resistance makes less power loss. Now, the length of how far you are from the power company affects that. There's nothing you can do about it. It turns out for a given amount of current, you can use a low resistivity material, so gold is much better than using copper or aluminum, but it's also much more expensive. There is a trick. If we could get the currents down, we'll find out that's one of the advantages of AC power over DC power. It was this I squared R loss that was really the limiting factor on Thomas Edison. So if you watch the History Channel, Men Who Built the World, Who Built America, and you've watched the whole argument between Tesla and Edison, this is what it was about. Anyway, that's how you calculate the power. Let's do an example. We have 6 amps flowing through both a resistor and a capacitor. The power of the capacitor is best found by doing VI, 4 volts. The power is going into it, so it's times 6 amps. So it is storing 24 watts. The resistor is not storing it, it's using up, and you can use VI for it, but I don't know V, so a better choice here would be using I squared R, since I know both of those. 6 amps, and I'm going to square that and multiply that by 5 ohms. So I have 36 times 5, or 180 watts are being used. The total power here has to be coming from this supply here. So in fact, there must be 204 watts being supplied by this device here, who's pushing it out, and I could use that in fact to find the voltage from that supply. Alright, that finishes this video.